For this question, we have to calculate the power associated with the two resistors, 5 ohm and 7 ohm respectively, which means we could use the formula voltage multiplied by current, or we could find only the voltage, use voltage squared divided by respective resistance, or current squared multiplied by respective resistance. So let's see which formula is easier to get first. So because we're having 3 current sources, let's distribute the currents first. I would note in here, I will denote node A, where the current that arrives into that node is 0.25 amps. It comes from the given source. Now, respectively, it is going to be distributed along 2 branches. So let's say to the right is going to be the current I1, and down through the resistors with the pipe ohm resistance value, let's say, goes the current I2. Now, current I1 carries on ahead, and on the way of I1 there are 3 branches, which I would combine all at the top together and call it a node B. So to that node B, I have a current of 2 amps going out, 1.25 amps going in, and respectively I will drop down current I3, which is going to be the current through the 7 ohm resistor. Again, the distribution of the directions, notation of the directions is arbitrary. If I end up on a negative value for the calculated current, this means that the original direction of the current was exactly the opposite. So my guess in here was wrong. So let's go ahead with the calculations right now. At this current stage, I could pull ahead an expression for the Kirchhoff's current law at node A. So Kirchhoff's current law at node A is going to look like 0.25 amps being the current in should equal the summation of the 2 currents out, I1 plus I2. And that's my first relation, so I will call it equation number 1. Then I will move to the Kirchhoff current law at node B, and in here it's a little bit more complicated. I have 2 currents in, they're I1 and then 1.25 coming from the source. They should equal the summation of the 2 currents out, which are the 2 amps plus the current I3. Now I need to reorganize a little bit that expression, so I1 minus I3 equals 2 minus 1.25, and from here I could just simplify I1 minus I3, giving me 0.75. And that is going to be my expression number 2. Now if I compare 1 and 2, I'm having 3 variables but still only 2 equations, so I have to pull a third equation. I cannot use any more nodes and current law, so let me tie it up with the Kirchhoff voltage. I will try to combine together the 2 voltage sources and the 5 and 7 are resistances which I'm going to calculate the power for. So my loop is going to be here. Kirchhoff voltage law at the loop the way I indicated, plus 7 multiplied by I3 minus E minus 5 multiplied by I2 is going to give me 0. A quick check that we did not forget anything. Okay, if we sort out this one better, 7I3 minus 5I2, that is going to give me 5, and let's call that expression number 3. Okay, now from here, I have a system of 3 equations with 3 variables. All I'm going to do is solve them. So, step by step from 2. From 2, I can pull that I1 is 0.75 plus I3, and I will bring this one to 1. So I will get 0.25 equals 0.75 plus I3 plus I2. If I simplify a little bit more, I will get an expression I3 plus I2 equals negative 0.5. And I will call this one expression nodal 4. So all I'm going to do right now is solve 3 and 4 together. Okay, solving 3 and 4, I could form I2 plus I3 equals negative 0.5, and then negative 5I2 plus 7I3 is going to be 5. I will simplify a little bit in here. To avoid matrix calculations, I will just multiply by 5. And I will add the 2 expressions, and I will end up on 12I3 equals 2.5. Okay, from here, I can pull out I3 being 5 over 24. Now the current I3, if I go back to the diagram, goes through the 7 ohm resistor, which means at this stage I could combine the 2 and calculate the power related to the 7 ohm resistor. So if I owe R3 the 7 ohm resistor, I could calculate the power for the 7th ohm, which is going to be I3 squared multiplied by R3. This calculation is going to give me an answer for the 7 ohm resistor, which I calculated as 0.3 watt. So here I go with the first answer for the 7 ohm resistor. Okay, now I have to do exactly the same for the 5 ohm resistor. So using the same system of equations between 3 and 4, I could calculate I2, and I2 is going to be the negative 0.5 minus I3, and I already have the value for I3, so if I plug it in the calculator, I will pull out negative 17 over 24. Now that value for the current I2 I can relate with the 5 pound resistor. So R2 is my 5 pound resistor. So from those two, I can pull the power related to the 5 ohm resistor, which is going to be the negative 17 over 24 squared multiplied by 5. And using the calculator, you could get immediately a quick answer of 2.5 watt. And that's the second part of the question. So at this stage, I'm ready with the 2 answers. I calculated the power associated with the 7 ohm resistor. It came out as 0.3 watt. And I calculated the power related to the 5 ohm resistor, which ended up being 2.5 watt.